So in this video, I want to talk about how you can construct a confidence interval for estimating the difference in two population proportions. And I'll also mention that this can be used if you're doing a two-tailed hypothesis test for the difference in proportions. So the statistic that we use for measuring or detecting these differences is, actually we take two sample proportions, so the proportion from population 1 and the proportion from population 2, and we look at the difference. And so I've said in previous videos that under certain conditions, this is this statistic, that's calculated by taking this difference, has an approximately normal distribution. And so we can use z-scores to construct confidence intervals for this difference. However, I'm going to just show you how this can be constructed using a TI-4 and how you can interpret the results. So I'm going to go to my stat menu and scroll over to the test, and I'm actually going to cheat and go up here to option B, which is this two proportion z interval, and hit enter. So in a previous example about a drug trial, has entered some data, and it actually has just carried over here. And so I've taken two samples. One had a sample size of 710, of which 107 had this certain characteristic. The second sample had a size of 611, of which 67 had this characteristic. I'm going to construct a, let's do a 90% confidence interval, and so calculate this. So the result that I get here is an interval with a lower bound and an upper bound. In this case, I'm getting 0.01072 and 0.07138. So I'm going to round this and say that this is about 1% and this is about 7%. So how do I interpret those results? So remember, I'm looking at the difference between some proportions. So I can say that I'm 95% confident that the difference in population proportions is between 1% and 7%. Now, keep in mind that these were both positive numbers, and so I'm saying that the difference is between 1% and 7%, and because of the order of subtraction, where I'm taking P1 minus P2, when both of these results are positive, I can be 95% that difference is between 1% and 7%, with P1 being larger because I'm getting a positive number when I do the subtraction. Now, if both of these were negative, well, first of all, the order would be reversed, and you would have negative 7% and negative 1%. Then I could still say that I'm 95% confident that the difference is between 1% and negative and 7%, but with P2 being larger. Because the results I'm getting are negative. Now, the interesting thing happens when one of these is negative and the other is positive. So notice now that the interval, if you think about, here's negative 7 and here's positive 1, included within this interval is 0. So if your confidence interval includes 0, basically what you're saying is that it's possible that these values are the same, and therefore, when you take P1 minus P2, that one would get 0. So that happens when these values are equal. Now, if your confidence interval includes 0, then basically your decision is going to be that you would fail to reject that null hypothesis. Fail to reject the null hypothesis if the confidence interval includes 0. Now, this is, of course, applies if you were doing a two-tailed test with a confidence interval for the difference in proportions. So that's how you can find the interval using your calculator, and then also how you can use that interval if you want to make a decision about a two-tailed hypothesis test. All right, so one last thing has to do with confidence intervals, and this would be if you need to calculate the minimum sample size. If you have a particular confidence level and margin of error. So the formula for this, if you have prior estimates, for two proportions, then you can take your p hat number 1 and 1 minus p hat number 1, add that to p hat number 2 times 1 minus p hat number 2. So then we're going to take this whole amount and then multiply that by z of alpha over 2 over e quantity squared. So this number is going to be based on your sea level, and then this is going to be a decimal margin of error. So let's say that I wanted to estimate something with 95% confidence, then I would use, let's see, let me think here. If I've got 95% confidence, then I'm using positive 1.96 and negative 1.96. Those are my z of alpha over 2. So if I wanted to have 95% confidence, I can use 1.96. And let's say I wanted my to make sure that my margin of error for the difference was no more than 5%. So I'll make this 0.05. Now, what if I had these prior the results from our previous example, where I had p hat number 1 was 15% and p hat number 2 is about 11%. So I would take my 15%, 0.15, and then 1 minus that, which would be 0.85. Multiply those together. Take the second value, which is 0.11, and its complement, which is 0.89. So I'll multiply those together. So 0.15 times 0.85 plus 0.11 times 0.89. And this whole result is 0.01248 and so forth. I want to multiply that by this quotient of 1.96 divided by 0.05 squared. And that gives me 19.18. Let me make sure 1.96 divided by 0.05 squared times 0.01248. Yep, okay. 19.18. I always want to round this number up, and so that would be 20. And so that's going to be the sample size that I would use for both groups. So I'll say that that's going to be for N1 equals N2 equals 20. I want to just check something here. I had 0.15 times 0.85 and 0.11 times 0.89. And I want to add those two together. So 0.1275 plus 0.0979. Yeah. So I don't know. I must have made a mistake earlier when I was doing this. Okay, that seemed like an awfully low number for a sample size. This should have been 0.2254. So let's do that one more time. I'm going to take 1.96 divided by 0.05, square that answer. So that's this divided by this squared, and then multiply that by 0.2254. All right, that should do it. So 346 and some change, and so I'll round that up to 347. Now that makes more sense for a sample size. Sorry about that. That was just a little calculation error there. All right, so that's how we can construct confidence intervals and calculate minimum sample size when we are looking for the difference in population proportions.